We're now starting our third and final look at factoring quadratics from grade 10 math. Factoring quadratics where our leading coefficient is something that isn't 1. We're going to look at our curricular outcome, review quadratic forms, and then figure out how to factor quadratics that don't start with 1. Our curricular outcome. We want to demonstrate an understanding of common factors and trinomial factoring concretely, pictorially, and symbolically. Review. When we have ax squared plus bx plus c and we can factor it, there will be two x-intercepts with rational number values, assuming we factor it with integer variables or integer coefficients. So the factors are going to be ax plus or minus b, cx plus or minus d, where a, b, c, and d are whole numbers. Not all quadratics can be factored this way. Some can't be factored with real numbers at all. Some can't be factored with rational numbers. Some just can't be factored. But if we go to the square roots of negative numbers, we can find the two factors for all of them. So, factoring quadratics where the first term or the leading coefficient is not 1. Well, all those rules we had for signs with the previous case apply here too. So if we have ax squared plus bx plus c, right, if c is positive, the signs and the coefficient are in the factors match. If c is negative, they don't. C is the product of our two constants, b and d. A is the product of our coefficients a and c. I should say lowercase a is the product of capital A and capital C. And our b term, the cross term, is a combination of AD minus BY or BC. Adding or subtracting depends on the signs on the actual values. We'll still have many more possible factoring options to check, but it's still finite. So previously we just had to find factors of what we are here calling lowercase c that would either add or subtract to make b. Now we have to deal with factors of a. Let's look at some examples. We're going to factor 6x squared minus 29x plus 35 if it's possible. All right, so a is 6. So our capital A and capital C, they're either 2 and 3 or 1 and 6. They have to multiply out to make 6. We're just looking at whole numbers. The constant term is positive, the linear is negative. So our b and d terms, when you factor it out, those numbers are both negative. Constant is positive, tells us the signs have to match. Linear term is negative, that says that they have to be the same. So if c is positive 35, so b and d are either negative 1 and negative 35 or negative 5 and negative 7. Now we could check all of our possibilities. So in this case, we have one option, x minus 5 times 6x minus 7. If we multiply that out, negative 5 and negative 7 make the positive 35. 1 times 6 make the 6x squared. Negative 30 minus 7x gives us a negative 7. Just to review, we're looking for a cross term or a linear term of negative 29x. So this one does not work. It gives us a negative 37 there. If we change the 5 and 7 around, we get a negative 42 minus 5, which is a negative 47. Still doesn't work. So it doesn't factor as 1 and 6 with 5 and 7. Let's try 2 and 3 with 5 and 7. Negative 10 minus 21 is a negative 31. That doesn't work. If we flip-flop 7 and 5, now we have a negative 15 minus 14. There's our negative 21. So in the end, yes, our fourth option here is the one that factors correctly. So let's factor 12x squared minus x minus 20 if possible. A is 12. So we have 3 possible pairs of values that multiply out to them to make 12. Constant term is negative, so they're going to have different signs. And in fact, that constant term is a negative 20. So they're either plus or minus 1 or plus or minus 20, plus and minus 2 and 10, or plus and minus 4 and 5. There are 18 possibilities to check here. We have 3 different values, or 3 different pairs for our quadratic. We have 3 different pairs for our constant. So you'd think that would be just that 3 times 3 or the 18. The 9 possibilities, because we also have to decide which is positive and which is negative. Each of them has 2 ways to arrange the sign. So systematically running through the 18 possibilities until we find one that works gives us 4x plus 5, 3x minus 4. We want to factor 2x squared plus 5x minus 17 if possible. We have a slight advantage here. 2 and 17 are both prime. So either they go together or they don't. Right? Our A and C have to be 1 and 2. Our B and D are either 1 and 17 or negative 1 and positive 17. If we try them, 2x minus 1 times x plus 17, that doesn't work. That cross term is wrong with the minus 33. The next one, also incorrect, also with the 33. It just changed the sign in the middle. So changing this one, so we have the 17 in with the 2. Still has the wrong cross term. It's still a minus 15 when we're looking for a plus 5. Our next option does produce a plus 15. This quadratic does not factor with rational numbers. So, exercises. Pause the video now. Take whatever time you need. All right. Sorry, so factoring this, it does factor to the 3x minus 2 and 5x plus 7. Exercise 2, 12x squared plus 56x plus 9. Pause now, take the time you need. Right, unpausing. This one does work out with 6x plus 1 and 2x plus 9. Exercise 3, 20x squared minus 17x minus 6. Pause now, take the time you need. This has no rational roots. We have to go to irrational numbers to solve the answer to this. So in summary, when a is not equal to 1, there are more possibilities to check for factors. The list will always be finite. If ax squared plus bx plus c factors, it'll factor in this form where we can figure out where the a and c terms come from. We find the signs that go with b and d, the same way we did before. We put it all together. Now, when you get to our next math course, you will see the quadratic formula where you can just take our lowercase a, b, and c. So you take this, this, and this, put those in the formula, and it will be solved. Until then, if you have any questions, any feedback, please leave it here, and I will do my best to respond in a timely fashion.